ورحمة الله وبركاته. بشرح درس 4.1 maximum and minimum values of a function using derivatives. This is basically application. We're gonna apply what we learned and just use derivatives in real situation. So these are called optimization problems, I think. What do we mean by a maximum and minimum? As we can see in this graph, minimum basically means the least value or the least something is, and maximum is basically the highest. So in this graph we can obviously infer that this value is the maximum, since there is no other value that is higher. Let's say if this went up there, this would be the maximum. However, this isn't the case, so this would be the maximum. So this is what we call a maximum. And here there is nothing lower than this one, then this is called a minimum. So we're gonna use derivatives to determine the minimum, the maximum, and stuff around these things. So let's see this definition. I think it's gonna help us. The definition says the absolute maximum is a value of f on the I think it's pretty obvious, no need to just read it, you can understand it sooner or later, but it basically means the highest value in this domain, and the absolute minimum is basically the same but as the least value. An absolute maximum, or we're talking about y values, or the what comes out of the function, obviously. An absolute maximum or minimum is sometimes called a global maximum or minimum. The maximum and minimum values of f are called extreme values of f. So we have let's just remove this. Okay, I'm sorry. Let's continue. Figure 2 shows a graph of function f with absolute maximum at d. So this is d, which is the x value, gives us a absolute maximum over here, and we note is the highest point on the graph, and we have f of a would give us the lowest point at the given graph. So let's say that if we restrict our view, let's just focus on this area, this one, from A to C, we notice that there is a highest value in this interval that we chose in this area, which would be B. This is the highest area here. This is what we call a local maximum. For this interval, this is a local maximum, and this one is also considered a local maximum if we choose C from E, so it would be the absolute maximum and the local maximum. So likewise, we have something called a local minimum and a local maximum. I don't think we need to check the definition. Is basically it is just that it's in the interval that we chose. I don't think I need to explain it. Let's just check this figure, which explains it bit better than the definition. So we see that f of 4 is a local minimum, since there is a lower value, but for, let's say, this interval, it is the lowest value. But if we check for the whole graph, this is the absolute minimum. However, this is the absolute max. This is the local maximum, since this would be a higher maximum for this graph. I don't think we need to read these. I don't think we need to read. Is there anything important in this one? I'm not sure. Let's just check the next one. So we have something called the extreme value theorem. If okay, I'm getting struck. If f of x is continuous on a closed interval, let's say something a to b, then f attains an absolute maximum value f of c and an absolute minimum value f of d at some numbers between these a b. So the extreme value theorem basically states that between let's say we have the interval a and b, we're gonna get okay, I'm sorry. So as we said, let's say we are given the interval a and b, there is a higher and a maximum and a minimum value between these. In this case, c would be the maximum and d would be the minimum. Another one here, we have a maximum and the minimum would be the same point, which is the as the minimum. Here we have a maximum and a minimum and a local maximum for, let's say this is a local maximum for b and d. So here is my notes since I wasn't paying attention in class. Maximum and minimum values. So they show that does not need to have a maximum or minimum if it doesn't meet the requirements, which are this one. These are the requirements. We said that it just must be be continuous, or it is asking about a certain interval. Let's see if there are any slides that are important. This one is just, it is, as long as it is continuous, it will have a maximum and minimum. So now we have our first name theory, or a theory with a name, which is okay. So I'm sorry for pausing so much, but let's continue. So Fermat's theorem: if f has a local maximum or minimum at c, and if prime of c exists, then f of prime c equals 0. So we need to understand something about derivatives. So derivatives basically mean the tangent line. So when let's say we have so when we check the minimum or maximum, or they mean the slope, the slope. So the slope here is basically 0 since it's not changing at all. So when we continue, so let's check if there are any examples. The function of, okay, we don't care about this one. Okay, just remove my notes. So Fermat's theorem does suggest that we should at least start looking for extreme values at f where, okay. So there is something, another definition is basically a critical number of a function is a number in the domain of f such that either f prime c equals 0 or f prime c does not exist. So Fermat's theorem can be replaced as follows: if it has a local maximum or minimum, then c is a critical number. Okay, how do we find the critical number of something? So we must find the derivative of the given function, then make it equal 0. So in this case it will be when we use the product rule, let's first do x 3/5 times it would be minus 1, so times minus 1, which basically means minus, plus, as we can see here, just gonna, I'm not sure if I'm gonna do it all, but let's try and do at least some of it. So we're gonna do 4 minus x, and then the derivative of this one, which is 3 over 5x, 1 minus 3 over 5, I mean 3 over 5 minus 1, which is gonna give us a minus 2 over 5. So as we can see here, it's the same solution. Now it's just gonna take, we're just gonna multiply by a, so when we have here minus 3 over 5 plus, now we're just gonna multiply this by all these factors or these numbers, and then we're gonna get this one. Then we can I think expand it more. Let me see what they did here. So from 3 okay, minus 5x, where did we get the 5 from? Oh, yeah, we multiplied. Okay, we multiplied here by 5x to the power of 2x. Now what we want to do when we have this a answer, this derivative, we must equalize it with 0. Now we just solve it normally, like a normal equation. We do whatever like we used to do. We just maybe multiply here by 5x to whatever, and just solve it normally, and we'll get the two values for x, or one value if we have one value. We're gonna have 12 minus 8x equals 0, which means that it equals 0. So f of x equals 0, so this is one critical number, so x would be equal to 0, and the other critical number would be 3 over 2. However, when we look at the original function, 0, this is the original function. When we use 0, it is not defined at 0. It doesn't exist, so 0 isn't an answer. So the only critical number is 3 over 2. Or 0 can be a critical number, I think. I'm not sure. We'll check here. So the same result could be here by if 0. Okay. Therefore f of 0, let's read this. F of okay equals 0, that is gonna give us 3 over 2, and f of prime x does not exist when x equals 0. Thus critical numbers are 3 over 2 and 0. So when we continue to find an absolute max, okay, I'm sorry for pausing again, but let's continue. So what we said is basically to find an absolute maximum or minimum of a continuous function in a given interval, we use the following steps. Find the values at the interval at a critical point. We do that by finding the derivative and making it equal 0. Finding the values of f at the endpoints of the interval, and the largest of the values is basically the absolute. So we'll just do something sort of like this, x and y. Let's see if there's an example so I can explain it more. Okay, so we have this interval. Let me open another notes yes, and a pop-up view, yes. Let's just write it here. So the function equals x to the power of 3 minus 3x squared plus 1. The interval is basically minus 1 over 2 and or this one is no, this one sorry, and 4. So sorry, but the math too is just slipping out. So let's solve this question. So first step is we find the critical points. How do we find the critical points? By finding the derivative first. So the derivative of f of x equals 3x squared minus 6x. This is a constant, so it just would go away. Now, we could also factorize. We could take, we could take 3 as a common factor, 3x. So we take 3x, and then we'll have x minus 2. This is all equal to 0. Now we could find the critical points. So our first critical point would be 3x equals 0, which means x equal 0. X minus 2 equals 0, so it basically means x equals 2. Now we would draw, this is not really a necessary step, but, or no, we'll save this for another time. So now we just, what we would do is do an x, y, is basically do a, as we've seen here in the steps, we find the values of the endpoint and the largest values from steps. So basically now what we would do is just do x and y, then we would do minus half, 0, 2 and 4. Now we would plug these into the equation. So once we plug it into the original equation, which is this one, it would be, so the first one minus half, so minus half cubed minus 3 minus half plus 1 is gonna give us a really high number, which is 1 over 8, or a low number, I mean. And if we have 0, so 0 minus 0 plus 1, so we would have 1. Hopefully it's clear, the numbers, I mean. Let me write it in a clearer way. 1 over 8, and here we have 1. Then if we plug in 2 into the equation, we would get minus 3, and then if we plug in 4, we would get 17. So out of these values, which one would you think is the maximum? I think it's pretty obvious that it is the last value. So this one would be the maximum, or the absolute maximum. And which of these would be the absolute minimum? It would be this one. This is the absolute minimum. Okay. So now we've found these numbers, so we now have the points that are the minimum and the maximum, as we can see in the graph. Okay, what the okay. As we can see, we have 2 and minus 3, which is this one, and 4 and 17, which is this one, and is really the maximum. So this is it for 4.1. Hopefully it's clear. I don't think it's too difficult. Hopefully you can solve the tutorial now. Cheers.